Hello everyone, welcome back to my channel. I'm Charmaine Chow, and welcome to Better Crash Course. So, I readjusted the camera. Before we begin, we have to do an iconic outfit of the day. But this skirt is from Forever 21. This top, it's like a weird neck thing. Don't like it, so I fold it down. It's from Hollister. And that is the outfit. The point of this video is to talk about hyperbolas and ellipses. Ellipses? Throughout this video, I'll give you examples of short and long, more complicated problems, as well as how they apply in real life. But first, let's go over some background terms. What is an ellipse? An ellipse, to put it in simpler terms, is a squished circle or something closer to an oval shape. It can be stretched vertically or horizontally. There are two foci located within the ellipse, a focus or foci for plural. It's kind of like a center point. The foci also helps determine how fat or how skinny the ellipse may be. In this case, we have two. Let's call one F and one G. And let's put another point called P. This P point will remain on the line of the ellipse. We are putting these points in to make things easier on the graph. Something to know is the distance from F, P to G is always constant or the same. Some other terms are the center. Center is also known as H, K, also known as X, Y. Kind of like a point on a graph. There is the minor axis and the major axis. The major axis is a point that's longer. That also helps determine if it's horizontally stretched or vertically stretched. The photo you see here is the standard equation of an ellipse. Now that we know what an ellipse is, let's find out what a hyperbola is. A hyperbola are two curves that either open up or down or left and right. There are many terms that go into labeling a hyperbola. For example, asymptotes are lines that help restrict where the hyperbola goes. There are two of them because there are two curves. This is the basic form of a hyperbola. Now that we know what a hyperbola and ellipse is, let's do some problems together. The first 5 we will be doing together are easier ones. The theme of it is just to know how to graph a hyperbola or ellipse when you're given an equation.
What's up, y'all? I'm kind of sick, but the show must go on. Anyways, this first problem is the easiest way to do it. So, first starting with an ellipse. Here we have the problem that is given to us. I'm going to quickly make a graph to help plot everything. This is the standard form of an ellipse. Looking at this, we can see that 1 is equal to A and 2 is equal to B. 2 is the bigger number, thus meaning it is a vertically stretched ellipse. Next problem, part B, is based on hyperbola. We are given this simple equation to graph. Here is the basic form of a hyperbola. Looking at this, we can tell that A is equal to 1, which is the foci, and B is equal to 2. Both of this is important because it helps with our asymptotes. The curving point of our hyperbola is where our foci is located, so just extend the legs from that. For some reason my screen got cut off, but B over A is how you find the slope of their asymptote. Now we will move on to harder problems, but are still graphing. Here is our equation. As you can see, the x has changed. But let's figure out what we know. We know 16 is a squared, thus meaning the square root of 16 is 4, or a. Same goes with b. Now, looking at the x plus 3, we actually do the opposite of what it says. So instead of right 3, it's actually left 3, or negative 3. Now, we no longer start at the origin. We start left 3 of the origin. 5 is our major axis, thus meaning this is again vertically stretched. Our third problem is an ellipse that's once again shifted in both the x and y direction. The square root of 36 is 6 and the square root of 4 is 2. Looking at the x and y, we can see that it's right 3 and up 1. Again, it's the opposite. This ellipse is horizontally stretched, and I know y'all that ain't the best graph, but I think it's pretty good. Now we're moving into hyperbolas. So this is the equation that is given. As you can see, there's a modification on the y. Looking at 16, we know that a is equal to 4 and b is equal to 3. The asymptote is determined by, again, b over a, so that's meaning 3 over 4. So now we draw in our asymptotes. From our a value, 4, we can draw our foci to get as close to the asymptotes as possible, but never touching. Okay, I don't know why it's cut off again, but this is another hyperbola problem, our last easy one. So now there is a shift from both the y and the x. Since the y is first, we know it's an up or down equation. We know that square root of 25 is 5, thus meaning that is b. Same goes with the 4. We figured out the asymptotes again with b over a. So now we graph.
Now we will be doing 3 hard problems. This is harder because you're not given the equations. Essentially, you're given the task to find the equation of a hyperbola or of an ellipse, given the foci and the distance between them. But just with that, we're able to determine what the equations are. What does this equation mean? Here's what you need to know. K, A, B, and C. C is also known as the location of the foci. K is important because we're going to use it to find A. K is known as a distance. For example, a point plus another point would equal this distance of K. A is equal to K divided by 2, thus meaning K is 2A. B is equal to the square root of A squared minus C squared. So now we have all our variables. So now look at the equations, we know what everything means. This will help us determine how to write them in their equation. For a vertically stretched ellipse, we will see this equation. Now looking at hyperbola. A left and right opening can be determined by looking at what's given to you. If it shows, for example, 1, 0, then we know it's left and right. 2, 0 is also left and right. We can tell that it's up or down if it's 0, 1 or 0, 2. Everything is the same. For example, A is still equal to K divided by 2, and C is still equal to the foci. The only thing that's different is the way you find B. B is equal to the square root of C squared minus A squared. As you can see, for an ellipse, it's A squared minus C squared. For an up and down, the B and the A are switched. Now, for the asymptotes, like I mentioned before, they are just lines. The equation for a line is y equals mx plus b. In this case, it is y equals plus or minus b over a x. Now with that information, we have determined what the equations for both an ellipse and a hyperbola mean. Now we can dive into the harder problems.
Hold on, because it's about to get hard. Our goal is to find the equation of a hyperbola or ellipse depending on the foci. It's going to be F, G, or A or B. This is the problem we're given to find the equation for the ellipse. Looking at our standard form, this is our goal that we want to achieve. We know that C, like I mentioned, is equal to the foci, which in this case is 2. B is equal to the square root of A squared minus C squared. K is equal to 6, which we got from here, and now we know what A is. So now that we have C and A, we can figure out what B is, which in this case is square root of 5. With this information, we can finally put it into our standard form equation. A is 3, thus meaning squaring 3 gives you 9. Now, squaring the square root of 5 gives us 5, thus meaning that is our answer. This is a horizontally stretched ellipse. Looking at this equation, we are solving for a vertically stretched ellipse. So we have found A, K, C. Now we're finding B, which ends up being the square root of 13. Now with all this information, we can put it together to form the equation of our ellipse. Squaring the square root of 13 gives you 13, and 7 squared gives you 49. Our last hard problem is focused around a hyperbola. Looking at this equation, we can tell it opens left and right. This is the form we're trying to get it in. We can pull out K, A, and C. Now we need to look for B. B is equal to the square root of C squared minus A squared. Thus meaning B equals the square root of 3. Now we can plug all this information in. Since x squared is over 1, we can just get rid of the 1. Square root of 3 squared is 3, so that is our answer. If you want to figure out the asymptote, you would do b over a. Like I'm saying here, the way you find b is one of the differences.
How does this apply in the real world? Ellipses can apply to space. Kepler's first law states that planets orbit in an ellipse shape. The sun is a focus, and there's another focus. This could be another planet or just another point in space. Knowing this helps determine the orbital period of a planet, to the point where the planet is closest to the sun. During this period, it travels the fastest, and from this you can draw a conclusion of how the Earth isn't consistently moving, because it is in orbital shape. And the further away it is from the sun's gravity, the weaker the gravity is. thus meaning the closer it is to the sun, the stronger the gravity pulls on planets like ours. That is just one extension. The way hyperbolas can apply in a bigger picture is in the use of spacecrafts. For example, when a spacecraft uses the gravity of a planet to alter its path, it forms a hyperbola shape. Now, I don't 100% know the math that's involved in this, but a hyperbola shape is achieved when it curves around a planet using its gravity. Sometimes this technique is called gravitational slingshot, because you are literally slingshotting a spacecraft using gravity. That is a way hyperbolas apply in the real world. Let's recap what we have gone over today, and hopefully what you have learned. We have discovered what hyperbola and ellipse are, what their equation is, what's the similarity and difference between them, how to not only graph but solve for their equations, and how they can apply to the real world. Thank you for watching Crash Course with Charmaine Chow. Hope to see you guys next time, whenever that will be. And don't worry, there will be a next time. Don't forget to check out my other videos, such as my AP Psych rap video. Thanks for watching. Bye! Located within an... I'm filming! Ugh, I can't see because I'm staring right at this damn light and I'm getting freaking green things in my eye. Disgusting! Okay.